Okay, welcome to Let's Get to the Marks. Today we're going through a question on KW. That's in your acids and bases chapter for A-level chemistry. So question 7, at 40 degrees, the ionic product of water KW is 2.92 times 10 to the minus 14. We've got a 3 marker here. It's give the expression for KW. That's going to get you 1 mark. Calculate the pH at 40 degrees, 1 mark. And give your answer to 2 dP. And that's 1 mark. So our expression for KW, you need to know this off by heart, is KW is equal to the hydrogen ion concentration multiplied by the hydroxide ion concentration. We show that using brackets, which stand for the concentration. Now, in order for us to calculate the pH, we need to find the hydrogen ion concentration because pH is equal to minus log the hydrogen ion concentration. So we need to do Kw equals the hydrogen ion concentration squared. Why can we do that? Well, for every water molecule that breaks down, you're going to get the same amount of hydrogen ions as hydroxide ions. So they're the same as each other. They're equal to each other in this situation, in which case we can square root both sides, i.e. square root Kw, 2.92 times 10 to the minus 14, jam it in the calculator, and what we should get is 1.708 times 10 to the minus 7, and that is the hydrogen ion concentration. Now we just need to do the minus log 1.708 times 10 to the minus 7. And if we do that, whack that in, we're going to get a pH of 6.767. Now it asked us for the final mark to round this to 2 decimal places. The 7 is bigger than the 6, so we're going to take that 6.76 up to 6.77. And there's your answer. So you get 1 mark for the expression, 1 mark for working out the pH, and then 1 mark for rounding up to 2 decimal places. And that's 3 lovely marks. Let's zing to the next part of the question. So 35 centimeter cubed of 0.150 mole per decimeter aqueous sodium hydroxide is mixed with 20 centimeters of 0.1 mole per decimeter hydrochloric acid. We got the same temperature, 40 degrees, which means the Kw is still going to equal 2.92 times 10 to the minus 14. Calculate the pH of the solution formed and give your answer to 2 dP, and this is 5 marks. First thing to notice is we've been given concentration and volume. Whenever you've got C and V, you know you need this triangle N over CV. So let's work it out for each of these things. We've got sodium hydroxide. So remember, for the volume, you've got to divide by 1,000. So every time you see 35 centimeters, whack 2 zeros in front is 0.035 times 0.150. We're going to work out the moles of sodium hydroxide in this reaction, and it's 0.00525 moles of sodium hydroxide. We're then going to divide 20 by 1,000, and we're working out the moles of hydrochloric acid. So we're going to get 0.02 decimeters of hydrochloric acid times the concentration 0.1, and it's going to give us 0.002 moles of hydrochloric acid. Now, these bad boys react 1 to 1. You might ask, why do they react 1 to 1? You can write the whole equation out, but if you just look at it, there's 1 OH on sodium hydroxide and 1 H on hydrochloric acid, and so they're going to come together to make 1 H2O, and that means that it's a 1 to 1 reaction. That means that we're going to use all of that hydrochloric acid up, but we're going to have some leftover sodium hydroxide, right? Because we had 0.00525 sodium hydroxide. Take away the 0.002 hydrochloric acid, you're going to be left with 0.00325 moles of sodium hydroxide left over. So now we can use the KW business. We've got the moles of sodium hydroxide. We now need to work out the concentration of sodium hydroxide. Okay, so, and we also need to bear in mind that sodium hydroxide is a strong base, and just like a strong acid, it will fully dissociate in solution. We've got that water hanging around from the reaction, and it's going to dissociate, and we're going to end up with 0.00325 moles of hydroxide ions hanging about. We need to work out that concentration of the hydroxide ions, which is equal to the concentration of the leftover sodium hydroxide. So there was a total of 35 centimeters and 20 centimeters of both solutions mixed together. That's 0.055 decimeters. Remember, divide by 1,000 to get the volume. We can do N over V, so moles over the volume, and we can get the concentration of the sodium hydroxide and hence the hydroxide ions. And the concentration of the sodium hydroxide is 0.0591. It's actually like 0.05908, but I've rounded to 591, and that is moles per decimeter, and that is the sodium hydroxide concentration that's left over, but it's also the hydroxide ion concentration. Now we know OH minus, we can use our KW expression again. KW is equal to H plus times OH minus. We can do, therefore we want to isolate H plus, so we're going to do KW divided by OH minus by bringing OH minus, dividing both sides by OH minus basically. So we're going to get 2.92 times 10 to the minus 14. Remember, this is happening at 40 degrees, so we're still using the same KW as we had in the start of the question. So when we smash that into the calculator, 2.92 times 10 to the minus 14 over 0.0591 mole per decimeter hydroxide ion concentration, we get 4.941 times 10 to the minus 13. So we just need to do the final step. That's the hydrogen ion concentration. So we just need to find the pH. Remember, it's the minus, press minus on your calculator, then the log, then 4.941 times 10 to the minus 13. So minus log the hydrogen ion concentration, and you're going to get a pH of 12.30, something like 7 or 308 or something like that. On my calculator, I got 12.306. Remember, it asked us for 2 decimal places. So as the 6 is bigger than 5, we go to 12.31. And that should get you all of the marks. Don't forget, sharing's caring. Hit the like, punch up the bell, subscribe. Let's get to the marks. Let's smash those exams. Don't forget to leave any comments down below. If you have any suggestions, you can also email me at letsgettothemarks@gmail.com and send me any questions you want me to go through in a walkthrough, and I'll make that video for you. Take care.
You're still here? It's over.